A sample of 50 people yielded the following information about their health insurance. Okay, so we have a number of people, type of insurance, managed care like an HMO, traditional insurance, like a PPO, and no insurance. So 2 people who provided information for the table were selected at random without replacement to determine the probability that neither had traditional insurance. So I'm going to say this is M for managed care, T for traditional, and N for no insurance. So we're looking at probability of no for the first one and no for the second one. That's going to be the probability of no, or N1, times the probability of N2. Probability of no for the first person is 7 out of 50, and for the second it would be 6 left out of 49. So the 7 and the 49 can cancel or reduce. The 6 and the 50, you could get a 3 there and get a 25 here. And we're looking at 3 over 175. How about the probability that both have a managed care plan? So that's the probability of managed for the first and managed for the second. Probability of M1 times probability of M2. It's 24 over 50 times 23 over 49. That's 552 over 2450, which is 276 over 1225, or approximately, or not even approximately. You can do exactly 0.225. In the third case, at least one had traditional insurance, so the probability of at least one had traditional, that's 1 minus the probability that none had traditional. So the probability of no traditional is going to be the probability of no traditional for the first one times the probability of no traditional for the second one. Okay, so if 19 are traditional, that means there are 31 non-traditional. And if the first one is gone now, that means there's one less non-traditional. That means 30 are left out of 49. That gives us 930 over 2450, which is 93 over 245. Make this a little bit smaller. Now, back to the previous one, 1 minus the probability of no traditional is 1 minus 93 over 245, and that is going to be 152 over 245. And the last one from this example, probably the first had traditional and the second had managed care, so this probability of T for the first and M for the second. That's probability of T1 times probability of M2. So probability of traditional for the first one is 19 out of 50. And then we have 24 HMO people out of 49 left because it's without replacement. This is 456 over 2450. It can be reduced to 228 over 1225. Okay. On to our last page then. So feel free to pause it if you need to write that down. Here we go. Which formula to use? This is from the book. I'm not sure those page numbers are correct though. In fact, no, I don't think these are even in the book anymore. So I'd probably cross that out. But it is sometimes difficult to determine, get rid of that, when to use the OR formula and when to use the AND formula. The following information may be helpful in deciding which formula to use. The OR formula, OR problems, will almost always contain the word OR in the statement of the problem. For example, determine the probability of selecting a heart or a 6. OR problems in this book generally involve only one selection. For example, one card is selected or one die is rolled. Whereas AND problems often do not use the word AND in the statement of the problem. For example, determine the probability that both cards selected are red, or determine the probability that none of those selected is a banana, are both AND type problems. AND problems in this book will generally involve more than one selection. For example, the problem may read 2 cards are selected or 3 coins are flipped.